Suppose let us consider a complete cycle. Okay.
Yes, sir.
Okay. Let us consider the points as this point as M, this point as B, C, and then D. Okay.
Yes, sir.
Firstly, average value. Average value of current. Okay. I average.
Yes, sir.
In a complete cycle, that is from O to D.
Yes, sir.
Okay. Let us consider it as current. Okay, fine. Now, you can see here it is. From O to M. From O to M. Current is increasing. And from M to B. Current is decreasing. Okay.
Yes, sir.
So, how much current is increased? That much current is decreased.
Decreased. Yes, sir.
So, total current in the positive half cycle is 0.
Yes, sir.
Okay, now.
Yes, sir.
Similarly, B to C, current decreases, and C to D, current increases.
So, yes, sir.
Okay, okay, now.
Yes, sir.
Okay, now. Fine.
So, yes, sir. Yes, sir.
Okay, so total current will be 0.
Yes, sir.
So, average value of current in a complete cycle will be 0.
Yes, sir.
Okay, now. Is it fine?
Yes, sir.
So, as average current is 0, so average voltage I can write as average current times the resistance of a conductor.
Yes, sir.
Okay, now. Fine.
Yes, sir.
So that means average voltage in a complete cycle is also 0.
0. Yes, sir.
Average voltage in a complete cycle is 0. Okay, now. Since we know
Yes,
that
sir.
power P is equal to rate of doing work,
Yes, sir.
right? So work done
Yes,
I
sir.
can write as charge times potential.
Yes, sir.
So power is equal to V times I. So
Yes,
in
sir.
a complete cycle, power will also be 0.
Yes, sir.
Okay, now.
Yes, sir.
Is it fine?
Yes, sir.
Okay, now.
Yes, sir.
Oh,
Completed, sir.
fine. So in a complete cycle, I can say that current is 0, voltage is 0, and power is also 0. Okay.
Yes, sir.
So average voltage means we can say that sum of the voltages by total number of intervals.
Yes, sir.
Suppose average voltage I am considering, that is V average equal to sum of the voltages. Suppose if I am having n number of intervals, then
Yes,
I can
sir.
write as V1 plus V2 plus V3 and so on to Vn by number of intervals.
Yes, sir.
Okay, na?
Yes, sir.
Similarly, average current, that is sum of the currents by number of intervals.
Yes, sir.
Okay, na?
Yes, sir.
Next, RMS means root mean square voltage. Okay.
Yes, sir.
Root. In short, we'll write it as RMS.
Okay, sir.
Okay. VRMS means, by definition, it says that
Yes, sir.
VRMS means under root square of the V1 square plus V2 square plus V3 square and so on to Vn square by n.
Yes, sir.
Okay, na?
Yes, sir.
Divided by n. Okay.
Okay, sir.
This RMS value, I think in last year in thermodynamics
Yes,
also
sir.
we got RMS speed.
Yes. Yes, sir. Mean eval. Yes, sir.
Right. So
Yes,
now
sir.
we are going to find for average voltage in a half cycle,
Okay, sir.
because in a complete cycle it is zero now.
0. Yes, sir.
In a complete cycle zero. So we are considering in a half cycle. Okay. In this
Okay,
half
sir.
cycle.
Okay, sir.
Either from O to B or B to D.
Yes, sir.
Okay, na?
Yes, sir.
This is one of the most important derivation for 3 marks.
Oh, okay, sir.
In the CBSE, they will ask the
Yes, sir.
one of the most important 3-mark question. Okay. Firstly,
Yes, sir.
I am finding the average value of voltage. From there, I will get average value of current.
Okay, sir.
Average value of voltage in a half cycle. Okay, na?
Yes, sir.
So by definition of average value, I know that sum of all the voltages by number of intervals. Right?
Yes, sir.
So suppose let us consider, I am considering an half cycle, this one, 0 to t by 2.
Yes, sir.
Okay, na?
Yes, sir.
Fine. Now what I am doing it is, I am considering an intervals. Okay,
Yes, sir.
like this. Each interval is having a time as dt.
Yes, sir.
Okay, na?
Yes, sir.
Like that, how many dt we don't know. Right now,
Okay, sir.
either it is n or 100 or 1000, we don't know.
Okay, sir.
Okay, so sum of the voltage. So I can write it as V average equal to sum of all the voltages in the time interval,
Yes, sir.
V dt. Right?
Yes, sir.
In the total time, that is integral dt.
Yes, sir.
Okay, where
Yes, sir.
we are integrating with respect to time, that is in
Time,
a
yes,
half
sir.
cycle, 0 to t by 2.
Yes, sir.
Okay, na? Since I know
Yes, sir.
that V is equal to V naught sine omega t,
Yes, sir.
so V average, I can say that integral 0 to t by 2 V naught sine omega t dt by integral 0 to t by 2 dt.
Yes, sir.
Okay, na? Here
Yes, sir.
V naught is a constant, bring it outside.
Yes, sir.
Integral sin x dx means I can write as minus cos theta
Classic.
minus
Yes,
cos
sir.
x. Instead
Yes,
of
sir.
t, we are having the omega t. So divided
Yes, sir.
by differentiation d by dt of omega t
Yes, sir.
between the values 0 to t by 2 whole divided by integral dt means I can write as t.
T, yes, sir.
Okay, na?
Yes,
So,
sir.
so can have that average voltage equal to minus V naught. See, in the denominator, d by dt of omega t is there,
Yes,
right?
sir.
D by dt of omega t
Yes.
means I can write as omega.
Okay. Yes, sir.
Okay, I'll bring this minus
Yes,
also
sir.
outside. So
Okay,
minus
sir.
V naught by omega cos omega t between the values from 0 to t by 2
Yes, sir.
divided by t between the value 0 to t by 2.
Yes, sir.
Apply the limits. Cos omega into, instead of small t, we are applying the final
by-
value minus initial value.
Yes, sir.
Omega t minus omega into 0 means 0 only,
Yes, sir.
by t by 2 minus 0. So it is, upon calculation, we will get minus 2 V naught by omega into t.
Yes, sir.
Since I know that omega into t means 2 pi,
Yes, sir.
okay, omega t equal to 2 pi. So omega t by 2 means pi, cos pi minus cos 0. Okay, na?
Yes, sir.
Okay. Omega into t means 2 pi. Cos pi means minus 1.
Fine. Yes, sir.
Okay. So upon
Yes, sir.
calculation, we will get as 2 V naught by pi.
Yes, sir.
So we can say that V average is equal to 2 V naught by pi,
Yes, sir.
right? Remember this
Yes, sir.
formula.
Okay, sir.
Okay, na?
Yes, sir.
This page completed.
Yes, sir. Completed, sir.
Okay, fine. This page.
So, yes, sir. 1 second, sir. So, yes, sir. Completed, sir.
Completed.
Yes, sir.
So here we got that it is average voltage,
Yes, sir.
average voltage in a half cycle. We got it as 2 V naught by pi.
Yes, sir.
Similarly, average current in a half cycle, I can write as I average. I can write as V average by resistance.
Yes, sir.
Okay, na?
Yes, sir.
Okay. So that is 2 V naught by pi into R.
Yes, sir.
V naught by R, I can write as instantaneous current.
Yes, sir.
So average value of current will be 2 I naught by pi.
Yes, sir.
Okay, na?
Yes, sir.
Is it fine?
Yes, sir. Fine, sir.
Okay. Now average value of voltage and average value of current is completed.
Yes, sir.
Next, I'll go to the RMS value of voltage in a half
Okay,
cycle.
sir.
In a half cycle. Okay.
Yeah, okay, sir.
That is RMS means root mean square.
Yes, sir.
Okay. Root
Yes, sir.
mean square. And remember that since we are finding for a half cycle, we are keeping the limits from 0 to t by 2.
Yes, sir.
You can see here 0 to t
Yes,
by
sir.
2.
Yes, sir.
Okay, fine. So by definition, I can say that V RMS square equal to sum of the squares of the voltage in each interval.
Yes,
So
sir.
integral V square dt by integral dt. Between the values from 0 to t by 2, because it is a
Yes, sir.
half cycle.
Yes, sir.
Okay, now since
Yes, sir.
we know that V is equal to V naught sin omega t. So
Yes, sir.
V RMS square is equal to, I can write as integral V naught square sin square omega t dt. Okay, integral
Yes,
0
sir.
to t by 2 dt. Can I write?
Yes, sir.
Okay, now is it fine?
Yes, sir. Fine, sir.
Okay. So V RMS square is equal to V RMS square is equal to V naught square is constant. Bring it outside.
Yes, sir.
Sin square omega t dt by integral 0 to t by 2 dt. Okay.
Yes, sir.
Since sin square omega t, we don't have direct formula.
Yes, sir.
So what I will write it is, since I know that cos 2 theta means 1 minus 2 sin square theta.
Yes, sir.
So 2 sin square theta, I can write as 1 minus cos 2 theta.
Yes, sir.
So instead of theta, we are having omega t.
Yes, sir.
So we can write it as V RMS square is equal to V naught square times, instead of sin square omega t, I will write as 1 minus
1 minus.
cos 2 omega t whole divided by 2 dt. In the denominator, if you integrate it, we'll get integral dt means t. Okay, na?
Yes, sir.
Fine. Up to here, is it fine?
Yes, sir.
Okay. This by 2, I will bring it outside.
Okay, sir.
V RMS square is equal to V naught square by 2 times integral 1 minus cos 2 omega t dt. If you apply limits, t by 2 minus 0, which will
Yes,
get
sir.
as t by 2.
T by 2.
Okay. Upon calculation,
Yes, sir.
we'll get V RMS square equal to V naught square by t. Now, I'll apply integration separately.
Okay, sir.
0 to t by 2 cos 2 omega t dt. Right?
Yes, sir.
So, V RMS square equal to V naught square by t. Integral dt means t.
T by 2. Yes, sir.
T. Next, integral cos x dx means I can write as sin x.
Fine. Yes, sir.
Instead of t, we are having the 2 omega t. So,
Yes, sir.
again, we need to do differentiation divided by d by dt of 2 omega t.
Yes, sir.
Okay, na?
Yes, sir.
Fine. So, V RMS square, if you apply the limits, V naught square by t, first, instead of t, I'll get t by 2
Yes, sir.
minus, this is 1 by 2 omega into sin 2 omega t.
Yes, sir.
between the limit 0 to t by 2.
T
Right?
by 2. Yes, sir. Yes, sir.
So V RMS square is equal to V naught square by T times T by 2 minus 1 by 2 omega sine 2 omega T between the values from 0 to T by 2. Okay.
Yes, sir.
Now I will apply the limits, that is 1 by 2 omega times sine 2 omega into T by 2 minus
Yes, sir.
sine 0.
Yes, sir.
Okay. Here omega into T, how can I write?
Pi, sir.
Omega into T 2 pi na
2 pi. Yes, sir. Yes, sir.
times sine 2 pi minus sine 0.
Yes, sir.
Okay. Sine 0 means
Yes, sir.
0. And remember
0.
that
Yes, sir.
sine n pi, where n belongs to set of natural numbers, that is 0.
Yes, sir. 0.
Okay,
Okay,
na?
sir. Okay, sir.
Fine. So we can write as V naught square by T, T by 2 minus 1 by 2 omega into 0 minus 0,
Yes, sir.
which will get as V naught square by 2, V
Yes, sir.
RMS square. So V RMS equal to V RMS square is equal to V naught square by 2. So V RMS is equal to V naught by root 2.
Yes, sir.
Okay, na? That is the RMS voltage in a half cycle.
Yes, sir.
Okay, this page completed.
Yes, sir.
Okay, this page.
Yes, sir.
Okay. This page.
Sir, that's 1 minute, sir. Yes, sir.
Okay, na? Completed.
Yes, sir. Yes, sir. Completed, sir.
This one also completed. So average, sorry, RMS voltage,
Yes, sir.
RMS voltage in a half cycle. RMS voltage in a half cycle, that is VRMS is equal to V naught by root 2. Okay,
Yes,
na?
sir. Yes, sir.
Fine. So similarly, RMS current in a half cycle, that is IRMS, I can write it as VRMS
sir.
by resistance.
Yes, sir.
Okay.
Yes, sir.
VRMS means V naught by root 2R.
Root 2R.
V naught means instantaneous voltage or peak voltage right now.
Yes, sir.
So peak voltage by resistance means peak current.
I naught. Yes, sir.
So IRMS I can write as I naught by root 2.
Yes, sir.
Okay. Remember the
Yes, sir.
values. RMS voltage and similarly RMS current.
Current. Okay, sir.
Okay, na? Right
Okay,
on.
sir.
Right on. Okay, na?
Yes, sir. Complete, sir.
Completed. Next. Suppose, let us consider I am having an XY plane. Okay, this is my origin.
Yes,
Okay.
sir.
Okay, fine. Now, let us consider the particle is lying along
Yes, sir.
x-axis. Along
Okay, sir.
x-axis. After some time, by applying a force, particle is
Yes,
moved to
sir.
the point P. Okay,
Yes, sir.
the particle moved to the point B with a constant angular velocity, such that we can say that it is particle is having an angular displacement.
Yes, sir.
Omega I can write as theta minus 0 by t minus 0.
Yes.
Okay.
Yes,
So
sir. Yes,
now
sir.
we will define the phase. Phase is defined as angular position of a particle with respect to
Yes,
axis.
sir.
With respect to
Yes, sir.
axis.
Yes, sir.
Okay. Phase is defined as angular position of a particle, angular position of a particle with respect to axis.
Yes, sir.
Here, with respect to x-axis, it is theta.
Yes, sir.
So what will be the angular position with respect to y-axis?
So 90 minus theta.
Right? 90 minus theta.
Yes, sir.
With
Yes,
respect
sir.
to x-axis, it is theta. So with
Theta.
respect to y-axis means I can write it as 90 minus theta.
Yes, sir.
Okay. Suppose if I drop a perpendicular here,
Yes, sir.
this is my displacement. And suppose let us consider point as E. So
Yes, sir.
I can say O to E is the horizontal component of R,
Yes, sir.
and EB is my vertical component.
Yes, sir.
In vectors, I can write OB bar equal to OE bar plus EB bar.
Yes, sir.
Right now, that
Yes, sir.
means R bar equal to XI
Yes, sir.
cap plus YJ cap.
Yes, sir.
Okay, now fine.
Yes, sir.
So I can write as, okay, Y is equal to R sin theta,
Yes, sir.
X is equal to R cos theta.
R cos theta. Yes, sir.
Okay. Suppose let us consider if the particle is moving in a circular path.
Yes, sir.
Okay. Suppose
Yes,
this
sir.
is my center. With the center of the path, we are
Yes,
considering
sir.
X and Y plane.
Yes, sir.
Okay.
Yes,
Firstly,
sir.
initially particle is at point A. By applying a force, particle is moved to the point B
Yes, sir.
such that it is having an angular displacement theta.
Yes, sir.
Now, at point A, what is the phase of particle with respect to x-axis. With respect to x-axis.
Yes,
What is?
sir.
Huh?
So
What is?
theta, sir.
No. Initially, particle is lying on x-axis.
So 0, sir, then.
Right?
Yes,
Whenever
sir.
the particle
Yes,
is
sir.
lying on x-axis, okay?
Yes, sir.
So,
Yes, sir.
the angular position of the particle with respect to axis we are finding.
Yes, sir. 0, sir.
So, it is 0.
Yes, sir.
Okay? Whenever it went
Yes,
to
sir.
B, then it is the angle. Right?
Angle, yes, sir. Okay, sir.
Instead of theta, I can write omega t.
Yes, sir.
R sin omega t.
Yes, sir.
See, here we are saying the displacement R. Okay? Last year, there is a chapter called oscillation.
Yes, sir.
In oscillation, we can say that particle is moving from mean position to extreme position.
Yes, sir.
Right? So, OB equal to
Yes, sir.
amplitude.
Yes, sir.
Okay, na?
Okay,
Can I
sir.
say? Can I say? So, Y is equal to A sin omega t is the general equation of the simple harmonic motion.
Yes, sir. Yes, sir. Yes, sir.
Okay, na? Right?
Yes, sir.
So, at point A, phase is 0.
Yes,
Phase
sir.
will indicate with phi, letter phi. Okay?
Yes, sir.
Okay. At time t equal to 0, this phase can be called as approach. Can be called as approach. Or we can say that it is initial phase.
Yes, sir.
Okay, na? Fine.
Yes, sir.
Initial phase or approach. At time t equal to 0, here we are having the initial phase is 0. Can I say?
Yes, sir.
Suppose now let us consider. This is my x-axis. This is my y-axis. Here it is the origin.
Yes, sir.
Now let us consider I am having a particle here. Okay.
Yes, sir.
Initially, it is having a phase as phi. Right?
Okay, sir.
Now, the particle is moved from point A to B, such that
Yes,
the
sir.
particle moved with an angular velocity omega. So,
Yes, sir.
the particle is having an angular displacement.
Yes, sir.
Okay. So,
Yes, sir.
then I can write the vertical displacement as A times sine of theta plus phi.
Yes, sir.
Okay. Instead of theta, I can write as omega t plus phi. Instead of theta,
Yes,
I'm
sir.
writing omega t, right?
Oh my God. Yes, sir.
Okay. That is the equation
Yes,
for
sir.
the particle executing in SHM,
Yes, sir.
or even in the waves also we got this equation.
Yes, sir. Yes, sir. Yes, sir.
Okay. Fine.
Yes, sir.
Okay. That is the brief description about waves.
Yes, sir.
Suppose let us consider an example. Y1 equal to 10 sine
Yes, sir.
omega into t. Okay. Y2 is
Okay,
equal
sir.
to 10 cos omega t. Okay, na?
Yes, sir.
Fine. So, what is the phase difference? Okay. Phase
Yes, sir.
difference of second wave with respect to first wave?
Yes, sir.
Now I can say that I need to find phase difference. I need to find phase
Yes,
difference
sir.
of the second wave with respect to first, right?
Yes, sir. Yes,
That
sir.
means what is the angle between cos omega t with respect to sin omega t? That is 90.
90, yes, sir.
90 degrees, na?
Yes, sir.
Okay. So
Yes, sir.
phi 2 minus phi 1 I need to find. Cos omega t, otherwise this one I can write it as plus 90,
Yes, sir.
because 10 sin omega t means I can write 10 into cos of 90 plus theta.
Yes, sir.
Sorry, 90 minus theta. Okay.
Yes, sir.
So phi 2 minus phi 1 will be plus 90. Okay,
Yes,
na?
sir.
Fine. Okay. Suppose let us consider V equal to V naught sin omega t and current I equal to I naught, okay, sin
Yes, sir.
omega t plus pi by 3. So then I can say that phase difference between current and voltage is pi by 3,
5/3. Yes, sir.
right? So I
Yes,
can
sir.
say that current
Yes, sir.
leads voltage by pi by 3.
Yes, sir.
Okay, na?
Yes, sir.
This phrase is important.
Okay, sir.
Next, suppose this is first one. Suppose V equal to V naught sin omega t and I
Yes,
is
sir.
equal to I naught sin omega t minus pi by 6.
Yes, sir.
Then we can say that current lags voltage.
Lakhs. Yes, sir.
Okay, na? Current
Yes,
lags
sir.
voltage by pi by 6.
Yes, sir.
Current lags voltage by pi by 6.
Yes, sir.
Okay, na? Right on. Okay, that will be the end. Okay, we'll meet in the next class.
Oh, okay, sir. Sure, sir. Thank you, sir.